Okay, so we have a mass weighing 20 pounds. It's going to stretch a spring 6 inches. The mass is released from rest at 9 inches below equilibrium. What is the equation of motion? Okay. So, all right, so the mass is going to be, okay. So the first thing to look for is, let's say, we're going to find, use Hooke's law to find the spring constant, okay? So, from Hooke's law, okay, so F is going to equal Ks. So 20 is going to equal K, now multiplied by 1/2. Because this has to be in pounds per foot. So if it stretches at 6 inches, that's half a foot, okay? So K is going to equal now 40 pounds per foot. Okay? And then we have to think of what is our mass? What is the mass of the problem? All right? So remember that force equals mass times acceleration. And what is the acceleration in this case? It is the force of gravity. So, if we're looking for the mass, that is going to equal 20 now divided by 32. We can simplify that out. That becomes 5 divided by 8. Okay? So you're always going to divide the pounds by gravity. Great. So, what is the, all right, so what is the problem that we're really trying to solve here? It's now second derivative of x with respect to time plus kx is 1 equals 0. Okay? So we have our m, which was 5 divided by 8. The second derivative with respect to time. Now plus 40 times x, which equals 0. Okay, so this is not exactly in standard form at this part. So why don't we multiply everything by 8 divided by 5? So if I multiply this guy by 8 over 5, well, if I divide it by 5, I'm going to get 8, so it's really 8 times 8, which is 64. Okay, so that gives us that the second derivative with respect to time plus 64x is going to equal 0. Okay? So, what does that give us? That gives us the auxiliary equation that m squared plus 64 is going to equal 0. Okay? Or that m squared is going to equal negative 64. You want to, that's what write the square root. Okay, so if we take the square root of both sides, the square root of 64 is going to be 8. And so the square root of negative 1 is I. And so m is going to equal plus or minus I times 8. Okay? So that's going to give us that x of t is going to equal now c1 cosine of 8t, okay, plus c2 8t. Okay. Okay. So at this point of the problem, we're going to look at what our initial conditions were to solve for C1 and C2. Okay, so let's ask the question about what are my initial conditions. Okay, so the problem states that the mass is released from rest at 9 inches below the equilibrium. Now remember, if you're below the equilibrium, that's when x is positive, okay? So you have to think about, well, okay, it's below the equilibrium point, so it's going to be positive, but I need this in B, okay? So there's 12 inches in a foot, so 9 divided by 12 would be the same thing as saying 3 divided by 4. So that's telling me, if I get to this problem, that x of 0 is going to equal 3 over 4. Okay? And what does it also say? Okay, so the mass is released from rest at 9 inches below equilibrium. So if it's released from rest, it's 9 inches below equilibrium, and you just let it go. You don't apply any initial velocity to it. So the thing just takes off by the natural motion of the spring. And so that other condition is telling you that x prime of 0 equals 0. Okay, so those are the two the initial conditions for this problem. So let's use those initial conditions and let's solve for C1 and C2. Okay, so let's use this initial condition first. Okay, so x of 0 is going to equal 34. 3 over 4, not 34. Okay, all right. So this would mean that 3 divided by 4 would equal now C1 cosine of 0 plus C2 now sine of 0. Okay. Well, sine of 0 is 0, cosine of 0 is 1. So what is this problem really telling me? This problem is telling me that C1 is going to equal 3 divided by 4. Okay. All right, and then I'm going to use the other condition. So x prime of 0 equals 0. Let's use this condition. X prime of 0 is going to equal 0. All right. So that's going to give me that 0 is going to equal. All right. Now C1, the derivative of cosine would be negative sine of 0. Well, times 8. And derivative of sine is cosine, so that's plus C2 cosine of 0. But it's also spitting out an 8. So sine of 0 is 0, and then cosine of 0 is 1. So what does this problem really tell me? This is telling me that C2 is going to equal 0. Okay? So my x of t is going to equal 3 divided by 4, now cosine of 8t. Okay, so and think about what this equation of motion is describing. There's no damping effect, and there's no external force applied upon this thing. So a cosine was always bounded between -1 and 1. So this this mass bouncing on this spring is just going to bounce back and forth between -3/4 foot and positive 3/4 foot. So it's going to go -9 inches and positive 9 inches, and just bounce back and forth, never stop.